Okay, welcome back. By this time you should have gone through the half-wave rectifier, understand the different waveforms of the half-wave rectifier, and understood which components are changing that waveform. What we're going to do now is build on that. That was a half wave, now we're going to do a full wave, and then we're going to do the bridge rectifier. This is the full wave. I've already had it built. I thought I'd save a little bit of time. All you're really doing is there's two things different between this and the half wave. If you notice, this is a different transformer. It has a center post. You can find that over here under transformers. That's the one you want to use. The other thing is we've added a diode. Other than that, it's pretty much the same. All right, so let's get into how this half wave works and what it does for us. First of all, we want to make sure we change our settings from 1 volt to 120 volts. Then on this one, instead of 10-to-1 ratio, let's do a 12-to-1 ratio. So a 12-to-1 ratio on 120 volts should give us 10 volts peak to peak on the other side of the transformer. Excuse me. This is the way we wire it up. Okay, you can just get a view of that. But now let's talk about how this current's going to flow. If you remember on the half wave, you could see the positive side of the waveform, but then it clipped off the bottom half, or the negative part of the waveform. I gave you kind of a straight line, and then you saw the positive again. This one, what we're doing is we're allowing the negative component of the waveform to be inverted. So in other words, it's flipping the negative side of the waveform, and you'll see that in the graph in just a minute. The positive side would flow through this diode to ground. The negative side, now we're allowing to flow through this diode to ground. So we're not clipping off the negative component of the waveform. All right, so what does this look like? Let's put a marker here first. We'll start with this one. What I want to do, after I start it here, okay, all right, now you'll see it goes from 0 to almost 5 volts, but let's change our settings so we can actually get a better picture. Let's go from minus 5.5. Remember, we're expecting a 10 volt peak to peak, so let's make sure we get it all in there. And now you can see it. We go up, now we're below 5, which we would expect because we still have that 0.7 volt drop across those diodes. So we're 0.7 volts below 5, which is perfect, 4.3 volts almost right there. But once that negative component starts, that waveform now flows through this diode, which then just inverts it. And so now, instead of a flat line here, or a clip, we actually invert that. And this is a full wave rectifier. So let's look at a couple other different points to help us understand what this looks like. Now if I go to this point then should give us our total peak to peak, which you can see it here. Let's see if I can stop it. There we go. So you can see what the waveform is coming into the diodes. It's a normal waveform. And then once it starts flowing through the diodes here, we take this negative component and we flip it. Hence why it's called a full waveform, because we're taking advantage of the entire waveform. We're just taking this and we're flipping it upside down. Or inverting it, I guess is the proper terminology. Okay, and if we even want to get more fancy, well, I'm not going to do that. I could put a probe right here and you could see the 120 volts, but that's going to make all of this and this very squatty, and we really don't need to see that. Notice here though, we can see that 0.7 volt drop. On this side, it hasn't gone through the diode yet, so we're actually 10 volts peak to peak, 5 volts up, 5 volts down. But once we hit that diode, we get cut off because of that 0.7 volt drop. Okay, so this is a full wave rectifier. Again, you can see it. It is a full wave. We're using the entire full wave, hence why it's called, I'm sorry, we're using the entire waveform, which is why it's called a full wave rectifier and not half wave. Hopefully you can see the difference between these two. The next one that we do is called a bridge rectifier. It's going to look very similar to this, but it's a little bit more stable, and you'll see what I mean.